for another episode of Uncertainty and Probability Theory, the Logic of Science. We're continuing our hypothesis testing segment. It's going to last several weeks, and it's already been a couple of weeks. This is episode 60. Does this guy have ESP? Now, all right, maybe you don't like ESP or anything like this, but I think it's a wonderful example because there's a lot of skeptical people about it. I'm skeptical too, but it demonstrates if you are skeptical and want to maintain that skepticism, if you sort of embrace hypothesis testing, you'd have to be led to accept it. So I want to use an example that doesn't get us thinking about all kind of different causal aspects of a problem, because nobody knows the causal aspects of ESP or something like this. So there's all kind of guesses and the like, but nobody knows anything about this. There's no absolute knowledge about this. So this will lead us away from any kind of distractions. Now remember, we review. What we want is some kind of a hypothesis. I put a little superscript for T for true. We want to know what the hypothesis is true. And our hypothesis, does this guy have ESP? We're going to go through a guy. Incidentally, I take this out of this book, which I give away free, but don't download it. I wrote this book back when I still was enamored of, when I went through my initial training as a student and, enjoyed p-values and all that kind of stuff. And I wrote that book with that kind of stuff in mind, and I now see it's all wrong. So I'm updating the book with things like this. Remember, we want this. We want the probability of this hypothesis is true. We want this in all of science. This is going to be a very but what we get is the probability of data not seen, assuming the hypothesis is false. And if that's small, if that's less than the magic number, then we infer that this thing is true, or very likely true, even though that's forbidden in the theory that gives you p-values. You're not allowed to give propositions probabilities, so they don't. Instead, they give them warm thoughts. They give them good feelings and so forth, that they're sort of true, but they don't attach a number to them. So like I said, there's nobody who is a consistent frequentist, or nobody who uses hypothesis tests that really believes frequentist theory. Nobody really does, although they might claim to. But I told you, this is almost trivially easy. Once you have a little bit of math under your belt, this is, especially if you have software that does it for you, it's effortless, just nothing to compute this and get this number. If you get this number and it's less than the magic value, if you get this, the calculation of this, and you spit out the number and it's less than the magic number, then you're allowed to claim the hypothesis is true. Or hint and, wink, wink, nod, nod, that kind of stuff, that the hypothesis is true. But this is very difficult. Now, last week, we did the lesson, lady testing T. And we said, okay, let's test whether the lady has the ability or not. And we went through, and I didn't even go through the whole thing. We were probably bored silly by the end of it, and I didn't even get to the math of it, and I said I might skip it, and I am going to skip it for this, which is very similar, but I think more concrete, easier to think about, less room for mistakes. We want this. We want to know what has the ability. So let's think about a standard ESP sort of experiment. I have here an ordinary deck of cards, and I'm going to. I shuffled them before off camera. You couldn't see me, but I did. I'm going to think of this. And you, in the future, are going to think of this card. Now, what do we know? We know there are 52 cards in this deck, and we know all the suits and the values of these cards and so forth. And you are going to guess, using your psychic powers of ESP, you're going to read my mind. I'm concentrating very hard on this. Okay, you can't do it because you're in the future and this has already been done and you don't know what this is going to be. So if I don't have ESP, and I'm going to go through each of these 52, I'm going to make you guess this one. I'm not going to tell you whether or not you're right or wrong, because we learned that could change. That's called feedback. And that could change the probabilities, that could change the knowledge that you have about future cards. For instance, if I told you were right every time or you were wrong, You know, if you can just simply count the cards, you know what's left and you can better guess. So I'm not going to tell you right or wrong, although there's all kind of feedback that you can get. You know, maybe I'm looking at this and you say what it is. Voila, 8 of diamonds. And you guess 8 of diamonds. I'm holding this up and things like this, and you guess 8 of diamonds. I'm not going to tell you whether you're right or wrong, but I go, I'm impressed because you got it right. Now that's subtle feedback. Maybe the person you're trying to test ESP gets that, or maybe they don't, but they might, and that gives them an indication. Now, you're never going to guess 8 of diamonds again if you know you're right. So that increases the chances you're going to get the rest of these right. So there's all kind of ways for this sensory feedback to come into play. Now, if you didn't have any ability whatsoever, and you were just guessing, there's no causal powers or anything like that, we might categorize. One way, if we want to quantify the ability that you would have, if you had no abilities whatsoever, or there's sensory leakage of some kind, or there's any number of ways that this could go wrong. The cards weren't shuffled, they came right out of the pack, and then they're all in order and all this kind of stuff. All those numbers, the ways we can go wrong, we could categorize the strength. I'll give this a psi 1 of being able to get 1 out of 52 for any given card, 1 out of 52. That's if you're guessing. That's if there's no causal powers involved or there's sensory leakage. You use that information to cheat, either knowingly or unknowingly, but if you didn't have it, you would never be able to do better than just guessing, knowing the rules of the game, that there's 52 cards and all that kind of stuff. So this is a pretty fair way of thinking about how what does not have the power means. So we want to think, what does have the power means? This means you don't have any psychic powers. 0 of 52 wouldn't be right, because somebody who's always wrong is just as useful as somebody who is always right. If somebody's going to predict the weather tomorrow and they always say rain and it's dry, or every time they say dry, it rains, that person's very useful. So 0 out of 52 wouldn't be a fair thing to look at, because that has some information. All right, so that's somebody who does have psychic powers. I have to go through this fast. I want to keep these videos under a half an hour, and I'm already blown through almost 8 minutes of this stuff here, and we haven't even got to anything important. This is why I'm demonstrating why this method is so hard, why this method of giving you the probability of the hypothesis is so much more difficult. I think I'm going to have to go more than a half an hour of this, or at least maybe bust the video up in 2. Okay, so in order to do all this kind of a thing, we need to have both of these methods use this idea of no power, no causal power of being able to actually read my mind or anything like this when we're doing these things, and therefore the chance we deduce the chance that is 1 over 52, because that's how many cards there are. And if you're just writing an algorithm that spits out a card, say, a card name, when there's no causal connection between spitting out the card name and what I'm holding up, well then 1 out of 52 is the probability of a match. If the probability was 2 out of 52, this person is got some level of psychic powers. This person has some ability. Not through cheating, not through anything like that, because we're supposing all the sensory leakage and all the cheating and everything goes into this 152 here, right? This, and they don't really have the power, even though the data might look like they have the power. This is still the truth, right? So here is somebody who genuinely has psychic powers. They're twice as good as the person without the powers. In other words, the probability they're going to be right is twice as high as the person who doesn't have powers. And here's another hypothesis that we might consider. Here's 3 out of 52. Well, there's all kind of hypotheses that we could consider. That's what we have to. This is the really hard work here. How many do I limit myself here to? All of them? Well, I mean, in a deck of cards, I can get 4 out of 52, 5. I can go all the way up to 52 out of 52. I can't do better than that. So it seems that we have, and 0 out of 52 would be a power 2. So maybe I should consider 0 out of 52. I could consider all these. I'd have 53 hypotheses. here I've only got one. I got the null, and we haven't talked about p-values, but here I only have that the hypothesis is false, which indicates this particular value right here, and all these others we don't think about. We just lump together. That's the bad part about this method right here. It doesn't force you to think about all of these things here. It just says assume doesn't have the power. Well, we agree that this means doesn't have the power. And the contrary of doesn't have the power means one of these must be true. But in ordinary hypothesis testing, they just blow all this stuff off and don't think about what it means to have the power. Instead, they just say it's not this, which means it's one of these. But we still have to think about these. We still have to think about what all of these kind of mean. This is why it's very difficult. So I need to think and of course it could be something else entirely from these, but we need to make it concrete. So let's go with these anyway. Let's suppose that this is a pretty good list, that 1 out of 52 means no powers, even if the data indicates it because of sensory leakage or something like this. Here's somebody who does have some psychic powers. They're able to guess maybe 2 out of 52, and someone even better still, 3 times the person without powers. Okay. Now, here's the way ordinary hypothesis testing would work. I've drawn up a little table right here, and I'm giving us the probability. Now we're going to go through the whole deck, right? We're going to go through this whole deck, and I'm going to keep track of the number of hits, which I'll call X. Number of hits, X. Of course, I could get 0. You and I together, when I go through the first one, you don't get the first one's King of Clubs, you don't get that, and I go through the whole deck, and you don't get any of them. That's 0 hits, or you might get just 1 or 2 or 3 or 4 or 5. I stopped at 5. There's 53 possibilities, but we'll stop at 4 or 5. You'll see why here in a second. Now, what's the probability? We're talking about getting the data now. What's the probability, assuming the person has no psychic powers, what's the probability of getting no hits? No hits. 36%. Or 0.36. I rounded all these out here to the nearest number just for the sake of ease of looking at these things on the board. If you're, this is another problem with classical statistics and everything. They're so concentrated on these probabilities to get them down to a fraction of a point, you know, or many decimal points or something like this. It's silly, because most people don't make decisions based on that. If you have to make a decision, you're dealing with billions of people, then you keep those levels of accuracy. Otherwise, this is fine. I always had the feeling I'm just blitzing through this stuff, and I think I am. I think I am blitzing through, and I wonder how much I'm losing people. You know, I don't get a lot of views on these videos, and I think the people who are sticking with it do get it, but I hope I'm not losing everybody for going too quick. And I see I'm already halfway through the 30 minutes, so there's no way I'm going to be able to make the whole thing. I'm going to bust this one up into 2 as well. There's no choice about that. So I'm going to bust this one up into 2, and I'll call this one number 1 up here. Does this guy have ESP number 1? Because there's no way to get it. So again, if you have no psychic powers, and you have this much ability, 1 out of 50, this is the ability that you have. You have 1 out of 52 ability of being able to get 1 out of 52, which we deduce. There's a 36% chance you'll go through the whole deck and never get any kind of hit. That's a pretty big hit. If you do have a little bit of psychic powers, twice as much as this guy, which is none, there's a 13% chance, only a 13% chance. Even if you have psychic powers, there's a 13% chance you're not going to get anything. And if you have, there's only a 5% chance, only a small 5% chance that you wouldn't get any if you have this much psychic powers, a 3 over 52. And so on down the line. You see here the probability is still highest for 1 hit. Here it's highest for 2 hits with the person with the 2 out of 52 psychic powers, and all of a sudden it's highest for at number 3. We have 3 hits out of the whole deck. There's a 23% chance of that under this hypothesis, and there's a 1% chance of this under this hypothesis, and so on and so on. But let's suppose we're going to pick 4. We got an experiment. I have to pick a number here to concentrate on. So we're going to concentrate on this particular number right here, number 4. This is the we ran through, you and I ran through this together, and there were 4 hits. All right. Now, this is us, me and you doing this experiment together. So I don't know if it's, and we can't tell from this particular result whether it's you being especially psychic and looking into my mind because you have this many hits, or it's maybe me being exceptionally powerfully, being able to transmit. I have a lot of power to transmit my thoughts into your mind, or both. We don't know if either of those are true, or either of us are just guessing, or I have no power and you have no power. So this whole idea of the full cause behind psychic abilities here, we haven't demonstrated that. No matter what we end up finding here, we're not going to be able to demonstrate all that kind of a thing. All right? We haven't demonstrated any particular theory of causation. There's the full formal, there's the full cause of things, which is the efficient cause, material formal, and the final cause. All of those are wrapped up in this and the conditions under which we're going to give them, like in the cards and all these kind of things. We haven't demonstrated any particular theory, even if the numbers turn out one way or the other, all right? We haven't demonstrated any of that, except for maybe we can, the one that seems to make sense is no causal powers, no ability, no power to either read minds, or maybe you can and I cannot transmit. And in this case, it'll seem something like this. We can't, under this experiment, do more than that. All right? So we're limited in what we can explain for our hypothesis up here, just by the experimental setup. We have to think about all of these things. All right, but let's do this. Now, I want to calculate the probability of data I did not see. I did, in fact, see a 4. We're going to assume we got 4 hits. All right? And I'm going to calculate the probability of data I did not see, assuming the hypothesis is false, have ability is false. So it means all of these others, I'm going to assume Y2, Y3, or whatever other ones we're entertaining are false, and Y1 therefore is true, the logical contrary. So I'm going to calculate the probability of greater than 4 hits. I didn't see 5 hits or 6 or 7 or 8 or 9 or 10. All the way, I didn't see any of that stuff, but I'm going to calculate the probability I did, assuming each of these, I'm going to assume this under the hypothesis is false. And that turns out to be 0.003, 3 out of 1,000. Now, the magic number, I think I've told you before. If you don't know it, you've probably seen it in science all the time. It's 0.05. This is, of course, less than 0.05 by an order of magnitude. We are therefore, we now say these results are statistically significant because this probability of seeing the data we did not see under this hypothesis is small. Therefore, we get this, we calculated that probability is 0.03. That's less than a magic number. We are now entitled to say one of these this hypothesis is true. Either this one or this one is true. Or this one we could say will imply as false, and any other hypothesis that we may conjecture. This is the crazy thing about it. It's not just that we're saying this one's false. We're rejecting this hypothesis. It's that we're saying this is false without, this is the real problem with the hypothesis testing. They never make clear what it is that they're accepting. They just reject this one. You can't, if you can't logically just reject one thing and not have something in mind for a replacement. In science, anyway. I mean, you can you can come up with scenarios and so forth. Here, this is an absurd thing to. This is a very precise hypothesis, and there's all these other hypotheses I might have. I might have 2.1 out of 52, 2.3 out of 52. I could have all of these other hypotheses here that might be true. We've said nothing about any of them except that we reject this because this number is so small. Well, we can go further. Some people will say, all right, let's calculate the probability of greater than 4 data we did not see, assuming this hypothesis. Well, it's 0.049. If that was our null hypothesis, we'd reject that too, because that's also less than the, we'd reject, this is very careful though, you gotta stick with me here. our null hypothesis, we'll just call this, for the sake of argument, our null hypothesis, right? We're going to entertain these three hypotheses here. We'll call this one our null hypothesis. We calculate the probability of data we did not see, assuming it is true, assuming it is, that is to say our hypothesis is, this is going to be our null hypothesis, the one we're going to accept, and we calculate the probability, and it's 0.049. So we reject this hypothesis, which logically means we must accept either this one or this one, which is nuts, right? Because this one we don't, if they have 2 out of 52, well, maybe it's not nuts, but this is stronger than this, but we're saying this one now might be true. We're saying either this one or this one is true, definitely, or with a wink, wink, nod, nod kind of a thing. It doesn't make any sense. So, but of course they would say, you can't make this your null hypothesis. This is your null hypothesis. Why can't you make it your null hypothesis? You can make anything you want your null hypothesis. That's an incredible limitation of, another limitation of hypothesis tests, this weird stricture they have on things. Now I could do the same thing with, of course, this hypothesis here, and I get 0.18. And I can, this is the other strange thing about this. Now, that's not less than the magic number. So I cannot reject this hypothesis. What I can say is I failed to reject it. I failed to reject it. And I must accept that one of these are true. All that's kind of nuts. Why don't we instead calculate this? Why don't we instead? We don't know the probability this is true. The hypothesis testing people would say the probability it's true is certain, or, you know, wink with a wink and so forth, without actually saying it's true. Or they say, well, maybe it's not true, but they can't give a probability to it, as we learned. So it's kind of vague, and you don't know what's going on. But we'd see, and the research shows ESP is you know, valid or something like this because of the statistically significant results. This is both of these are statistically significant results. All right, well, instead, let's calculate the probability this is true. Now, all we got to do is use all the probability apparatus that we have up to here. It's just Bayes' formula. And I didn't write it up here because I don't have the time, but it'll be at the blog. I didn't have the board space, wmbriggs.com, wmbriggs.substack.com. And it's basically just the probability of the data times our prior probability that we judge each of these things based on whatever historical evidence we're going to use. We have to talk about that. Okay, so let's suppose, and then you just divide by, you know, it's just Bayes' theorem. We just do Bayes' theorem. I'll have the formula on the website. But we just do Bayes' theorem, and I seem to have the idea that I should tell you. Let me give you the formula here. We want the probability of which one, each of these are true. But let's just do psi 1. We could do Bayes' theorem for any of these, given the data we have seen and whatever evidence we started on. That's going to be the probability of the data given psi 1 evidence times the probability of psi 1 given the evidence divided by the sum over I, if you like, of the probability of x given psi I e, then probability of psi I e. Okay, that's Bayes' theorem. That's what we want right there. And we could swap in a 2, put a 2 here, a 2 here, or a 3, a 3 here, a 3. We could calculate the probability. Each of these are true. Given the data we've seen, we're going to still stick with our 4 for our example here, and whatever initial evidence that we have. Now, this is the other really hard part about this particular way of doing things. We've already seen we had to think hard about what it is, what other alternate hypotheses that we're willing to consider. Now remember, all probability is conditional on whatever that you assume. So it doesn't mean that because I've only assumed these particular hypotheses that other hypotheses are impossible. That's not true, unless we can deduce that it's not true. In this case, I'm only using these 3. You are free to use other possible hypotheses in here. Other alternate hypotheses besides this particular one that you might have good evidence for. And so that has to be done in every single problem. I'm just picking what I think are maybe representative other hypotheses that we might look at here. And I'm not exhausting every hypothesis that there is out there, all right? That's crucial. That's the really wicked part about this. Now, if I want to convey my results to the public after I've given this particular example right here, I've given this person the test, it was you, and we ran through, and you got 4. Now I've calculated these probabilities, which we see we need here, and we need here. And now I need to multiply them by the probability that we initially have evidence for or against each of these hypotheses. And you notice now I have to have evidence for each of these. I have to have a probability for each of them. These are all the hypotheses I'm considering. Therefore, I have to have probabilities for each of them. There's a lot more work in this. There's just a lot more work, and I have to think about how I'm going to do all these kind of things. All right? So one way to do it, I wrote it up here. This particular table that I've calculated here, this right here. This is the probability that psi, either 1, 2, or 3 is true, given x is 4, the number of hits are 4, and e. So one thing we might do, it's kind of small, is I might say, well, I don't know that much about ESP. I'm willing to think that this is, by whatever prior evidence that I have, this is the hard part about communicating this stuff. This right here, I'm going to say has a 1/3 probability. This thing has a 1/3 probability, and this thing has 1/3 probability. Why not? That may be the evidence that I'm willing to look at this stuff. You got to understand, when you're communicating results, this is why I picked telepathy or ESP as an example, because there's going to be people who are very skeptical, right? I mean, there'll be some people who say it's absolutely impossible. I give it a probability of 0. Well, fine. That's fine. You could say that. And if you do, then none of this stuff makes any difference. No data that you'd see makes any difference whatsoever, right? But you got to sort of be willing to have a gun be held to your head and say, you know, if it turns out to be true, can I pop you? If you are absolutely certain, positive, 100% satisfied, then you'd say yes, that it's false. All right, but other people might say, well, I think this is, I'm going to give you lots of examples here, but not today. I'm going to give you more examples about this. But if you're dogmatic, you can be dogmatic. It's fine to be dogmatic about necessary truths, for instance. That's what necessary truths are. So it's not dogmatism that's wrong. Dogmatism is never wrong. It's only dogmatism about things that are not necessarily true that's wrong. When you make an error, that is to say. So that's the only time that probability or logic goes wrong, is when you're wrong about something that you thought was a universal and necessary truth, but turns out to only be a local truth. In other words, one of your premises was wrong in whatever argument you have. All right, but somebody who might be more willing to believe all this stuff, they might be dogmatic in the other way. They might give this one 0 probability and allocate the probability among these other psychic power hypotheses. And that's just going to give you the same thing too. Again, there's no reason to give this result. There's no reason to give these results if all you're interested in is saying whether or not someone has the power, because you've decided beforehand that they do. You can't be convinced by any evidence either. So both sides of this question, if they come across as dogmatic, there's no reason to do the experiment whatsoever. For the people who are absolute skeptics and the people who are absolute true believers, both of these people are immune to evidence, okay? Which only works for for contingent things. If you're holding views about the world of contingent things, it's very dangerous to do that because they're contingent. That's to say, the world, we did this a long time ago, necessary and contingent truths and local truths and all that kind of stuff. The world is not set up such that it has to be that psychic powers exist or they don't exist. And being dogmatic about that is dangerous, because if you're dogmatic about it, you'll never, if new evidence comes along one way or the other, you're going to be stubbornly defending something that's wrong. All right. So I ran out of time, and I haven't even got to the main results. And there's a trick and a twist coming, a big trick and a big twist coming. And I have to show that to you. So I'm going to stop here, and I'm going to just stop the video, and I'm going to pick up the cards I spilled all over the floor, and I'm going to start right back up and do part 2 of this. I don't want to go more than a half an hour. All right, that's it. Thanks for watching. WMBriggs.com, WMBriggsSubstack.com, and thanks for watching.